Greetings! Today I have a power supply to look at and to play with, and this is what it looks like. It came in a bag. There is a number on the bag that says 9516 and it's a 5 volt 500 milliamps, a 5 volt 5 amp power supply, and this was sent to me from ICStation, ICStation.com, the shop that sells all sorts of weird and wonderful gizmos and gadgets. So let's have a look on the website and see where it came from and look at the actual listing. So I'm going to try to screen record this on the website on the laptop, something I've not been doing previously. So let's have a look. So let's go to ICStation.com and press record. 3, 2, 1, and we are recording. So yeah, ICStation sent this to me in order for me to have a look at it. So let's try to find it on the website. It was 5 volts 500 milliamp. I've already searched for it, so if you type in just 5 volt 500 milliamps, it will find it straight away, and there it is. By the way, the ICStation wanted me to mention that they will be having a huge discount and mysterious gifts during Black Friday. So if you want to enjoy a mysterious gift, whatever that is, head over to there on Black Friday, and yeah, you can use the discount code I will pop in the video description. It's a 5 volt 5 amp switching power supply module, 5000 milliamp AC/DC converter, price $5.15. So it's roughly £3.41. So it's really cheap, this. And let's look maybe at the pictures. Okay, let's go to this one. And it's already on the pictures. It seems like it's got wires that have been cut off, which is a little bit strange. Here is the back of the board, and here is someone holding it, and clearly there has been wires soldered onto this, but they have been cut off, and I was wondering why, but I think I've got it figured out, so I will show you in a moment. So let's remove the module from the bag and have a look at the actual PCB of what have we got on there. There it is, that's the front of the PCB, and looking around, it's exactly as in the pictures, precisely. So there is even a little bit of a haze on this side over here. So let's get a little bit closer and overlook. The board's a little bit not cleaned up. There's some flux residue on there, but okay, not a biggie. There are those little square rubber pads on here that are meant to serve as a little spacer, so you can place it on top of surface. And clearly the wires over here that's been soldered, input and output wires, were a manual job, because no one cleaned it up again. But as I said, that's okay, we can do that ourselves. I don't mind doing that when I buy a really cheap product or when I get one. This area here is where we've got the common mode choke on the other side, and you can see over here those little teeth, jagged edges over here. Those are spark gaps, and those are for protection in case high voltage spike. The pointy edge of this will make the spark jump across of here and prevent further damage to the unit. And here we have the actual control chip. Is it upside down? NE1109F. And without doubt it's a switch mode power supply controller, but we'll have a look at the datasheet in a moment. And further on we've got some discrete components, more of those little pads, and here's the isolation between the hot and cold side, or live and not live. This side over here is mains on the left, and the one on the right is the low voltage side. The isolation on this is reasonable. There isn't anything obvious that come across both sides, apart from the heat sinks. It's worth noting though, the heat sinks over here, it's a piece of metal that goes across both high and low side. So yeah, this is potentially an issue, but what they've done, they've actually used multiple layers. So this heatsink here is attached on the low voltage side. So anywhere from where the low voltage side ends all the way to the end, the heatsink has been wrapped in multiple layers of some sort of tape around, and it's basically isolated, and it's not staked down anywhere on the high voltage side. And the same with the other one. The other one is staked down on the high voltage side, but as soon as it leaves the high voltage area, it's been wrapped up around again with multiple layers of the yellow transformer type of tape. And yeah, that's okay, but that will reduce the actual heat dissipation of the heatsink. But perhaps this was calculated, perhaps this was an afterthought, I'm not sure, but that's what it is. It's yeah, it's not a potential to get a short circuit across, so it should be fine. And then on the low voltage side, there is a few passives, a few transistors, and that's about it. On the other side, again looking from this side, so yeah, this is the mains input and those are the wires cut off. They have been held with some sort of elastic, and yeah, there's a provision to put in a input jack over here, which you could do, and there's the common mode choke, there's a bridge rectifier over here, class X2 capacitor, 270 volts AC rated. Over here there was a provision for NTC thermistor and fuse F1, which have not been fitted for whatever reason, but then we've got the MOV and a fuse F2, which has been fitted. So we've got a fuse over here, and this one and this one are in series, so potentially what can be done, you can attach another fuse slightly lower rated, because this one would prevent you from a huge gross overload, but you could put a slightly smaller fuse within the rating, get it wired up to the outside of the panel of a device that you're going to mount this in, and this will allow you to have an easy access to change the fuse if needed. Here is the main capacitor on the high voltage side, so that's 100 microfarad 400 volt, and it's not being held in place with any elastic, which again, there isn't much room to move, but if I was to put it somewhere where it's prone to maybe jerking around, this I would put something in here. Interestingly, there is some elastic on here, but it looks like it's been cut off, and what I think it is this cap has been replaced, but more on that in a moment. Over here we've got a transformer that again, it does show some signs of use, and we have a date code, which is 1408. So my conclusion is on this board, this power supply, was actually in some sort of equipment for quite a bit of time, and what someone's had an idea. They probably got a hold of a lot of those, and they've decided to pull them all out, recap them, because this cap seems a little bit different than everyone else. It's just different brand. I'm not sure what brand that is, but it just doesn't follow the pattern. Usually it would be the same as every other cap, and those say Jamicon on there. Also, looking at the back of it, seems the soldering on the high voltage electrolytic cap is a little bit different. It's been, you can tell that this was hand soldered in afterwards, and everything else was wave soldered. Yeah, someone's had an idea to, pull those out, recap them, and make them usable again. ICStation probably has got found a supplier of an inexpensive power supply and wanted to get it out to the market, and there we go. We've got an inexpensive 5 volt 5 amp power supply for £3.40. You can't really complain. It's obvious at this point that this was kind of refurbished. Yeah, just be aware, it is a refurbished power supply. Let's have a look at the performance. So let's wire it up to some fresh cables and power it up and see how much current we can draw out of it. Before I do anything, I'm going to desolder those wires from input and output, and connect some proper connectors on here, or proper wires with a plug. And I've got a cable with a switch and a plug that I'm going to solder onto this, just to make sure. We've got live on this side, so live goes here through a fuse, and neutral goes directly into the common mode choke, right? It will work otherwise as well, but in case the device fails because of a short circuit or anything else, the live gets disconnected. If it was the other way around, that would mean even when your device failed, it's still live with mains voltage on. And I'm going to put a zip tie through here to hold the cable and prevent the stress from happening on the joints. Okay, I've got it connected to the multimeter first, and just to see whether we'll get the promised 5 volts on the output. In terms of output, I looked at the last cap over here, and the negative is on the outside of the board, and that goes directly to one of the solder pads for the cable. So the 5 volts should be, sorry, the negative should be this one, which I've connected to black. That goes into the multimeter on volts. Make sure I don't touch it. So here goes nothing yet. Now that's because the switch is switched off. Now this switch doesn't provide any safety because it's a single pole switch, so yeah, this still could be live even if the switch is switched off. So if you use one of those, just be careful. You need a double pole switch to fully isolate a device. So let's power on. Instantly we get 5.3 volts, which is good. So far so good. It gives us the 5 volts. So let's try to put it under some load. Here is the test setup. Let me make sure this is all visible. So though this meter will be showing volts, the output at the end of those flimsy wires over here, that we will attempt to put 5 amps through them, and this one will measure the current. And here is my current load, which I can adjust the current that we're drawing out of the device. Let's begin the test, and I'll increase the current draw over here. Now I don't think I will be able to get the full 5 amps out of this, because at 5 volts the constant current load will probably drop somewhere under 2.5 amps. There we go, we've got 2.3 amps and still 5.1 volts on the output, 2.6. Right, okay, I think that's it, 2.67. I'm going up, but it's not having it. That's just a flaw with the design of this. I'll be able to draw 5-10 amps out of this through this load if the voltage under test was higher. I need to modify this because it's beginning to annoy me. And here is test setup number 2. The multimeters in here have got the same function as previously, so this one's measuring the voltage, this one's measuring amp. But instead of the constant current load, what I've got here is a section of Cantle wire, resistance wire, and at full length this has got about 10 ohms, but we can just touch it in any point that we want to draw as much current as we want, and this will get very hot presumably. So let's have a look. So let's power it up. Okay, we've got our 5.3 volts, and if I attach it here, I think I've switched it off this way. There we go. We've got 720 milliamps. Now mind you, the voltages are showing a little bit low because there's quite a bit more voltage drop in the cables that are going across this whole thing. We've got 780 milliamps. That's 1 amp. Let's go all the way closer, 1.3 amps. Okay, 2.7 amps, and the wire is smoking a little bit, so okay, that's 2.8 amps, 3.5 amps. It's beginning to glow, so let's try a little bit lower, maybe here, 3.6, 4.15, yeah, there we go. So we've got 4.2 amps. Okay, let's try something else. So what I've done now actually in order to get the better readings, I've connected the voltmeter directly across the terminals on the board, and we'll be able to still draw different amounts of current over here. So one more time, let's power this up this way. There we go, our 5.3 volts, and current, let's see, that's 1.5 amps. So let's go back where we were before, that's 2.6 amps, 3 amps, and the voltage is holding 5.25 volts on the output. So most of the voltage drop was across my flimsy cables, that's why I had to change the setup. So let's see here, 3.5 amps, so still above 5. My resistance wire is glowing. Let's try here. Okay, 4.2 amps, and it's getting really hot. Okay, 3.5, 3.7, 4.2. Oh, so looking at this, I'm able to draw 4 amps. But somewhere above 4.2 amps, it's there is a protection circuit on here that kicks in and just stops. There you go, 4.2. If I go a little bit closer, one more time, 4 amps, 4.2. No, it's not. When I get anywhere closer where the 4.2 is, it's not very happy. Yeah, 4.26. So no, it's having trouble to deliver the actual 5 amps. Now this hasn't got anything to do with flimsy wires on here. Though if it was, if the wires were too thin, they would just get hot and melt down. But this experiment shows me 2 things. Number one is the device on the test over here is not going to put out 5 amps no matter what. It seems to be cutting off at 4.26, maybe 4.3 amps. And you can see the voltage jumping back and forth. As soon as I remove the load, it goes back up. But the second thing that it tells me, it's got a protection circuit. It has got a way of measuring if it's overloaded. It protects itself, which is a good thing. So yeah, I'd call that actually a 4 amp power supply, not a 5 amp, 4.2 at most. I actually got a project in mind and I needed about 4 amp power supply. This was 5, so it was a little bit over the top, but it's still perfect for my purpose. It's not having it. You can see the voltage jumping back and forth, so that's the protection trying to start up the switch mode converter, but load is too high and it's not having it. If we go a little bit further away, let's let it start up. Okay, that's back up, and we touch it here. There we go, 4 amps. It will draw quite happily for a long period of time. And here is the datasheet for that NE1109 chip, and it's a power supply PWM controller, and yeah, applications general 10 to 65 watt power supply, AC adaptive, high performance notebook PCs, printer, and I think that this circuit came out of a power brick. That's what it was designed for, one of those, you know, like laptop style power supplies. because when I look at the form factor, it fits the bill. It's exactly the right size to fit into those standard power bricks. If we changed one of those two resistors, we would be able to get the full 5 amps out of it, most likely. I'm not sure how the rest of the circuitry would handle it. By changing this ratio a little bit, just to make sure that it's sensing a little bit off what it's sensing right now, we'd be able to get the full 5 amps out of it. But as it is right now, as we saw earlier on, it's not quite happy drawing 5 amps. There it is. I think that's all I can say about this right now. It's a power supply. It's 5 volts output. Nothing wrong with the voltage on the output, but it will not supply 5 amps as stated. So I would call that 4 amp power supply, maybe 4.2 as we saw. Anything more than that, it puts it into a shutdown mode. Now here is a power brick, just a generic power brick. This one's a 12 volt 5 amps, slightly taller, but the form factor fits the bill. You know, it's right that. From brick to brick they will be a little bit different. This one's a little bit taller, but yeah, that's your standard power supply thing. As it says in the datasheet of that little chip, it's designed for laptop and whatnot power supplies, and it's a nice design, really compact. It's 4 amps is still plenty for what I want to do with this, but I think ICStation got a little bit misinformed by one of their suppliers on what are they selling. Yeah, ICStation, this is what it is, but it might be worth amending the listing over there, because or more importantly, talk to your supplier, because this is not I think what you paid for in order to get it into your store. So there we go. I hope you enjoyed this little journey of testing and looking at this power supply brick insights. And yes, if you did enjoy it, please make sure to give me a like under the video and leave a comment to say what you think about it. Please also share those videos as much as you like, and thank you very much for staying me this long if you're still here, and for the time being, take care.